Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shamimi Amira binti Sabri and I'm from Group 9 of Engineering Team Project. So my friend and I are going to present about problem 3, which is administration building. Today I'm going to present about the project overview. So basically our group has been proposed to design the electrical installation system of an administration building. We need to redesign the provided layout of this electrical installation system by using AutoCAD. Along the way, to redesign this system, we need to consider many things such as power factor correction board, main switchboard, and also cable sizing with the load calculation. This is because we need to ensure that the electrical system will operate in an optimum condition without disturbing daily operation. So here we got two problem statements for this project. The first one is the load with low power factor. When the load has low power factor, it will consume more current compared to a load with high power factor. So when this happens, the excessive heat generated will damage or shorten the equipment life. So the second one is the MB will charge a higher cost. This is because it's due to the overcurrent condition that occurred before. So the building will have a higher electricity bill. In life, everything we do, we need to have goals or objective. So the objective of this project is to reduce the power consumption of this building by at least 5 to 10% of its original value with the possible lowest operation cost. We also need to ensure that all the consideration be taken seriously, especially safety and also environmental consideration. So for the scope of this project, the first one is we need to design a low voltage distribution system for this building. Secondly, we need to redesign the distribution board, sub-switchboard and also the main switchboard. We need to make sure every level has a balanced system. So we need to perform all the load calculations such as lightings, fans and also air conditioning. Lastly, we have to choose the suitable protective device and cable selection by referring some datasheet to ensure that the system is safe to be used.
Assalamualaikum warahmatullahi wabarakatuh. I am Syed Zulkama bin Syahrir. I will continue the presentation. My part is lighting in administration building. Okay, for illumination for the area of building. In any building, we must accurately measure the area before calculating the number of lamps. The size of the area may have affected the amount of lamp required for space. The specific area has their own standard of illumination. It is according to the IES and GKR standard. So to make sure that the amount of lamp must be determined. This is often done by calculating the lumen method. The lumen method is used to calculate the average of illuminance on working place. By doing the calculation, we can ensure the lighting is placed on the right spot to produce the specified of illuminance. Okay, first we must find the room index. The formula given is the K is equal to the L times W over HM times L plus W. To calculate the room index, we must have the data about the length of room L, width of room W, and mounting height of luminaire above the working place, which is HM. HM we can get the data from the datasheet. Okay. Why we must calculate the room index? The reason is to find the COU. COU is the coefficient of utilization factor. Then we can find the actual lamp quantity in the building by using quantity lamp calculation formula. Okay, the formula is N is equal to the EAV times L times W over LDL times COU times MF. Okay, so to perform this calculation, many factor, coefficient, lamp lumen data, and therefore the quantity must be gathered. For EAV, COU, and LDL, we refer to their own table, their own JKR and IES standard to get the value. Okay, for MF value, we use 0.8 in this project. Okay, next is the calculation of total connected load and total maximum demand. Okay, first we must calculate the total connected load of each load, TCL for each load. Okay, the formula is TCL of each load is equal to the quantity of lamp times connected load. For the connected load value, we can get the data from the datasheet provided, and then we sum up the total connected load of each load to gain total connected load of every level, which means the total of each level. And then we calculate the maximum demand of each load by multiply the total connected load of each load with diversity factor. The diversity factor value also we can get from the datasheet. Okay, next is for existing design, which is the original design. From the layout provided, the total connected load are calculated to find the power consumption for each level. Okay, the uses of lighting are depend on the area at the building. So the total connected load for this building that we get is 240.232 kilowatt, and the maximum demand for this building is 130.04 kilowatt. So we will compare the result with the quantity of lamp in the provided layout. Okay, the task for this project is to reduce the power consumption of the original design at least 5 to 10%. So we must propose option 1 and option 2 to achieve it. Okay, for option 1, we must reduce the power consumption by reducing the number of load in the building. The layout was redesigned with fewer total number of lamps than the original design. The lighting calculation method was used to determine the actual lamp quantity for every specific area and room. The calculation depends on the illumination lux and illuminated area. Thus, the total actual lamp quantity was calculated. Overall, the total connected load for this building is 237.820 kilowatt, and the maximum demand for this building is 128.110 kilowatt. Okay, based on this calculation that have been done, the option 1 is managed to reduce 6.2% of power consumption. Next is the option 2. For option 2, the design was the same as option 1, but most of the lamp were replaced by the LED tube, which is 16 watt LED tube and 8 watt LED tube. Why we use LED tube or LED light? Because it is more efficient compared to other lamp, and it is used about 50% less electricity. Moreover, it has longer lifetime than the other. Okay, for the total connected load for this building is 211.35 kilowatt, and the maximum demand is 96.257 kilowatt. Okay, the option 2 is managed to reduce 14% of power consumption for each level. Okay, next is for lighting design. The LED lamp that we choose for our project is 2 times 16 watt LED tube FTG with 6 watt low ballast aluminum parabolic reflector. Second is 2 times 8 watt LED tube FTG with 6 watt low ballast aluminum parabolic reflector. Third is 1 times 16 watt LED tube with 6 watt low ballast, and last one is 1.8 watt LED tube with 6 watt low ballast. All of the LED lamp we use Philips brand. Okay, we continue to the size of wiring selection. Okay, the cable size of domestic lighting and fan circuit usually fed by 1.5 mm square and earth cable, which has 2 core and earth. Okay, for circuit breaker rating, every lighting circuit uses ampere rated MCB. Okay, the function of MCB is to protect them from the potentially damaging thermal and dynamic stress of any overcurrent. Assalamualaikum warahmatullahi wabarakatuh. Okay, I will continue to the SWOT analysis.
And circuit breaker and cable size. First day I will start by socket. And all the type of socket we used in this building are 13 ampere switch socket outlet PVC modulate. and we use this three formula to get total connected load and maximum demand and ratio current, and we assume the factor is 0.85. The 13 ampere switch socket is the best choice because the 13 ampere socket with the voice blink are that any appliance with the loading not exceeding 3.12 kilowatt by connected with a perfect safety to any 13 ampere socket. Diversity factor refer to table loading, maximum demand and diversity, where the table has the function of the final circuit supplied by conductors or switchgear to which diversity relates, and this is also the ratio of the total of the total individual maximum demand of the different sub-definition of the system. And second thing, the protective device or circuit breaker. The protection device is important device in the electrical circuit. In this building, electrical circuit modulate cases circuit breaker are used. This circuit breaker act to protect the entire electrical system from overloading and have such condition of short circuit issues. The current rating for the modulate case circuit breaker at distribution board of the lighting and the fan are 6 ampere, while modulate case circuit breaker of the socket is 16 ampere. The current rating selection for circuit breaker for the sub switch board and the main switch board depended on the design circuit. The third thing, the selection cable. The selection cable need to be considered carefully. The cable selection is based on the current rating. One of the requirements for the cable, it must be able to withstand the heat produced by flowing current. For this building, the current rating has been determined for choosing the suitable cable. The copper conductor cable with the earth wire are proposed for this building, and the size for cable, and we choose 4 type of size for this building. First size for lighting and fan, we choose 1.5 millimeter square, and for Scott outlet we choose 2.5 millimeter square, and for distribution board and sub switch board we choose 6 millimeter square, and from sub switch board to main switch board we choose 50 millimeter square. And thank you.
Assalamualaikum. My name is Muhammad Faris bin Fauzi. I'm going to present about the selection of protection device, selection of cables, cable sizing, and distribution board. For the selection of protection device, there are 4 factors that we need to consider to choose the protection device. Firstly is the circuit load characteristic. Second, the disconnection time requirement for the circuit. Third, the prospective fault current. And fourth is the current capacity carrying the cables. For our building, we have choose MCCB as our protection device. The function of MCCB is to protect all the electrical system at the building from overloading and having conditions such as short circuit issue. The current rating for the protection device at the distribution board is divided into 2. First is lighting and fan, and second is for the socket. For lighting, 6 ampere is used as the current rating, and for the socket, 16 ampere is used. For the SSB and MSB, the current rating is depends on the design current that we have calculated. Next is selection the cable. One of the most important thing to choose a cable that the cable must be able to withstand the heat generated by the flowing current. Second, the cable must follow the provided guideline so that it can avoid the unnecessary incident occur at the building because of the cable. For this building, we have choose the type of cable for the lighting and fan, socket, SSB and MSB. For the lighting and fan, we have choose the PVC cable. For the SSB and MSB, we have choose the copper conductor cable. Next, I'm going to talk about cable sizing. For the cable sizing, we must know its color rating before we propose the actual size of the cable. For the lighting and fan SSB, MSB, we have referred the current rating table to propose the size of the cable. For the lighting and fan, we have choose 1.5 mm square for the cable. For the SSB, we have choose 6 mm square for the size of the cable, and MSB, we have choose 50 mm square for the size of the cable. For the socket, we have proposed the size of the cable by referring to the Malaysian practice 13 ampere socket outlet. From that, we have choose 2.5 mm square as the size of the cable, since the socket we use is single socket outlet. Then, I'm going to talk about distribution board. The distribution board is designed based on the option that we have selected. The option 2 have been selected. The requirement for the distribution board, each final circuit must not exceed 1000 watt and not more than 10 units of load. For the distribution board table, we need to calculate the total connected load and maximum demand. For the cable red, yellow, blue, we must calculate the rated current using the formula of maximum demand over voltage. Based on the calculation, we design the distribution board using AutoCAD software. As a result, there are 12 units of distribution board of lighting and fan and 12 units of distribution board for the socket at this administration building.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dua Azwa bin Abdul Razak. My matric number is 10109097. I will present to you about the sub-switch board, SSB. SSB is the electrical device that can distribute electricity from one source to another. Major component of SSB is used in processing power distribution. Then, SSB is functioning to monitor the flow of power of the building. In our design, SSB is connected between MSB and DB. The incoming SSB is connected from MSB, and the outgoing SSB is supplied to DB. Next, I will explain to you about the protection device. Protection device is used to protect the component, machinery, equipment, and devices of electrical or an electronic circuit against short circuit and overcurrent. There are two types of protection device. The first one is miniature circuit breaker, MCB, and second is molded circuit breaker, MCCB. So these two MCB and MCCB is used for current protection, and it is important to include in this SSB for safety of the building and the distribution board. Tables in the slide shows. The first one is table of SSB to DB. Second, table of SSB to MSB. So I will explain to you how to collect the data from those tables. And So the first one is the sizing of MCCB is determined by the maximum demand MD, and then the rating MCCB is determined by the design current calculation. So after those calculations, we have decided to choose 60 mm square for sizing cable for SSB to DB and 50 mm square for cable SSB to MSB. So the calculation of voltage drop for both table is using by the same formula that shows in the slide and all the calculation can be referred to appendix SSB.
Assalamualaikum and hi. My name is Nur Shamimi Amira binti Sabri and I'm going to present about the main switchboard. So what is MSB? MSB is a assembled unit of electrotechnical components. It is used for receiving, measuring and distribution of electrical energy and also protects the network. MSB also an equipment that automatically switch from primary power supply channel to backup in case of problems with the supply of electricity, such as emergency cases. MSB is an important and responsible part of electricity network as it helps to avoid power loss and downtime in production. Lastly, MSB enable to record the energy as well as make the control of the power. So there are many types of protection devices such as fuses and circuit breakers. They are used to protect the circuits, wires and components from the circuit overload. An overload condition happens when there's too much current flowing through the circuit. It can damage components and wiring that are sensitive to high current. So there are also various types of circuit breakers such as molded case circuit breaker, miniature circuit breaker and also air circuit breaker. So among them, they also have differences between them. So what is molded case circuit breaker? MCCB is used to disconnect when loaded with current that exceeding its capacity. MCCB has ability to deliver maximum current that are greater than MCB. MCCB capability reaches 1000 ampere. So for this building, we had choose a suitable MCCB rating, which is MCCB 4.0. For miniature circuit breaker, it is also an automatic electrical switch that will disconnect the electrical circuit when the current exceeds in the specified amount. So after the calculation had been done, this building has 125 ampere of MCB rating. Lastly, the air circuit breaker. ACB is a circuit breaker that is used to utilize the air of an arcing of the arc when the ACB is turned on. But for this building, we don't use ACB. We only use MCCB and also MCB. Next, we have power factor correction. Power factor is an important consideration to ensure the efficient and effective use of electricity. It is also used to reduce the reactive power and also power cost drop proportion. Next, it also helps to fuel voltage drop and improve voltage regulation. Lastly, all electrical equipment's kVA rating will be reduced after power factor correction has been done. So here we have capacitor bank. So basically, capacitor bank or power factor corrector has two types of compensation. So the first one is individual compensation, which means that the power factor correction is wired at each single of the load. So the second one is central compensation. There is only one bank of capacitor on the main power distribution. So it is best suited for the system where the load fluctuated. As we can see, there are a total of 12 steps in calculating the capacitor bank. So for this building, all the calculation has been done by using specified formula and specification in installing the capacitor bank. So that's all for me. Thank you.
Few advantages for our project. First one is the power usage of this building can be reduced. The cost of electricity monthly will be decreased, and this building will become the eco-friendly building because LED was chosen. And in this context, LED does not release carbon dioxide gas that can be harmful for the environment and the public health. And last but not least, the electrical system for this design is work efficiently. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, I will continue to the SWOT analysis. Okay, what is SWOT? SWOT stands for strengths, weakness, opportunities, and threats. Okay, so SWOT analysis is a technique for assessing these four aspects of work. Okay, the function of SWOT analysis is to reduce the chances of failure by understanding what are lacking and eliminating hazard that is unaware. The advantages of SWOT analysis: it can help to uncover the opportunities. Knowing about the weakness, you can manage the weakness and eliminate all the threats. Okay, the SWOT that we get is for strength. The option 2 design compared to existing design has decreased the lighting load. So the strength is it more efficient when using option 2 design. Okay, for the weakness, replacing ineffective lighting system with more advanced ones will initially spend some cost. So basically, the weakness is we use a lot of money to replace the lighting system. Okay, for opportunity, it can trigger to the technological innovation. For example, we can use green energy because the excessive consumption of electricity result to the negative impact on our environment. Okay, the last one is street. The total harmonic distortion is possible to be high because the appliance is mainly consuming electrical power. So basically, the trick is we need to calculate many times to get the right size of power factor. That's all from me. Thank you.
As a conclusion, the option 2 have been chosen because it reduces a lot of power consumption compared to option 1. The option 2 have reduced power consumption about 24%, while option 1 only reduced the power consumption about 6%. Based on that, we can conclude that by replacing the fluorescent lamp with the LED lamp, it can help to reduce the power consumption. We know that the LED lamp has low output power, but it is more efficient compared to the fluorescent lamp. Last but not least, every step in designing the electrical system at the building, it must follow the correct guideline. This is to avoid the unnecessary incident occur at the building. Why I said this? Most of the incident occur at a building. It is caused by the failure of the electrical system. That's all from our group.